in this section, we're talking about functions. So the first thing I want to kind of go over is to remember how to tell if a graph of something is a function. We have what's called the vertical line test, right? So like if we have a graph that say is like a parabola. So like to see if the graph of that is a function, you have to like draw the lines through, and if it crosses the graph at more than one point, then it is not a function. But like if anywhere on the graph, like this line I draw through only touches the function like at one point, or only touches the like equation at one point, then it is a function.
You mean like across the axis?
Not the axis, the actual like shape. Like here, let me. So like if it crosses like my green shape, if it. Right, so like if I draw a vertical line at any point through it, if it touches my graph at more than one spot on that vertical line, it's not a function. So like if I had this, right, this would not be a function, because if I draw a vertical line through it, I'm touching here and here. Does that make sense? I was like, Rebecca, your eyes say absolutely not.
Okay, just say all over again and then...
Okay. So, when you're looking at a graph,
okay,
any graph, whatever shape, to tell just by looking at the graph, without knowing the equation or anything else, if it's a function, you can draw vertical lines through the different points of your graph. And if it only touches the vertical lines you draw, if they only touch at one point, in your shape, then it is a function. Like, but if at any point you can draw a vertical line through it and it's going to touch your shape at 2 points on that same line, then it's not a function. All right, so with that, we can also determine just by looking at these pictures, like the original graph, if the inverse of that is also going to be a function. So for that one, it would be the horizontal line test. Right, so all right, so let's just kind of stick with the parabola. Let's say, let me draw it in green. Right, so if there's our parabola. So we know that it is a function because it passes the vertical line test, right? We just did that on this previous slide. But if we wanted to know if the inverse of this function is also a function, we're going to learn how to find the inverse in a little bit, but
Do you not just flip it upside down?
no, it flips it over. It flips it over like this point, so it like reflects over that y equals x line. So really, it like kind of flips it sideways.
It just kind of like tilts it.
Yeah, essentially, sort of. But to tell if whatever the inverse is going to be a function, it has to also pass the horizontal line test. So that means if you draw a horizontal line through it, it can only touch at one point. But this one touches at 2 points, right? So the inverse, so it doesn't pass the horizontal line test. So therefore, the inverse is not a function. Right, and so since the inverse is not a function, that means that this is not a one-to-one function. You'll see that in the book. So a one-to-one function basically just means that the equation itself is a function and the inverse is also a function. Like, so they both have to pass the vertical and horizontal line test to be one-to-one. out of room. BA1, 2, 1 function.
Because it hits it at twice, it's not a function?
It's the inverse of it is not a function.
Not.
Right.
Okay.
So let's look at one that is. So let's say we have, let's say we have a graph that looks like this. Right, so this one would pass the vertical line test, right? This little green one I drew. Right, so. And it also, too far, would pass the horizontal line test. Right, so this one would be a one-to-one function because it's going to pass both the vertical and horizontal line test. Examples of that. Yeah, all right, so. All right, so let's say that we have a function that's f of x is equal to negative 3x plus 2. So the easiest way to do this to find the inverse is we're going to take f of x and rewrite it as y, because they mean the same thing. But it's just easier to work with y instead of that f of x. So we know that y equals negative 3x plus 2. So you can always interchange f of x and y. The next thing we're going to do is we are going to swap our variables. So wherever there's a y, we're going to write an x. Wherever there's an x, we're going to change it to a y. Right, so that means that our new equation is going to be x equals negative 3y plus 2. All right, and then after we do that, we're going to solve our new equation for y. So we just want to get y by itself. So we're going to subtract 2. So we have x minus 2 equals negative 3y. And divide by negative 3. So y equals, sorry, I was having recording issues. X minus 2 over negative 3. So that's your inverse function. If you wanted to write it with function notation, it would be f negative 1 of x is x minus 2 over 3. So that's inverse notation. So when you see that f negative 1 of x, that means it's talking about the inverse of a function. So I'm good if you write it either of these two ways.
Negative 1 means inverse?
Yeah, the little superscript negative 1 by the function it does anyway. Right.
It's like a
Exponent. Yes. Oh, yes it does. Thank you.
Haven't we done it?
Yes, we did it in algebra 2.
It seems.
Yeah, we did. I think it was I'm pretty sure we did it right at the beginning when we started remote learning though. Last year.
Yeah.
Yeah, we did, because we did it before logarithms and stuff.
I remember the FX and all that stuff, but I don't remember what it was.
Yeah, well, that's part of why we're going back over it. So I wanted to kind of reinforce it. Huh?
My haircut?
Oh, yeah. Look.
Back on the mold.
See that. So that's really all I have here for notes. You just swap them and then solve it again for y. Do you guys have any other questions?
That's all for 7.3. That's all we
Mhm.
have to know.
Yep.
What's
Page 149, 15 to 24. 4 and 1 through 6. I don't know why I didn't say that.
Can I go get my-
Yeah.
So 1 through 6.
1 through 6 and 15 through 24. Oh, wait. Nope. Through 22, sorry.